This is Chapter 5, Host, Application, and Data Security. These are three of the most important elements to secure in any information technology setting. The host, which can either be a server or a client on the network, runs applications that process, save, or transport data. So one of the most important aspects of host security is also the most obvious, securing those devices. We secure those devices so that no unauthorized users can get to them to obtain physical access to the equipment. So the first and foremost in security is physical security. And the first type of physical security would be some kind of lock. The standard keyed entry lock is the most common type of door lock for keeping out intruders, but its security is fairly minimal. Deadbolt locks are much more difficult to defeat. And to achieve the best security when using any kind of keyed door lock is to follow a key management procedure. Some of the procedures that are recommended is to change locks immediately upon a loss or theft of a key, inspect locks on a regular basis, issue keys only to authorized persons, keep records of who uses and turns in keys, keep track of the keys issued, both for masters and duplicate keys. Master keys should not have marks identifying them as such. Secure unused keys in a locked safe. Set up a procedure to monitor the use of all locks and keys and update the procedure as necessary. And make sure that your master keys are marked do not duplicate. An alternative type of lock, is a little more sophisticated, is a cipher lock. Cipher locks are basically combination locks that use buttons which must be pushed in the proper sequence to open the door. Cipher locks also keep a record of when the door was opened and by which code. A disadvantage of cipher locks is that they can be vulnerable to shoulder surfing, so make sure people cannot see the buttons that are pushed. There are currently proximity readers. Instead of using a key or entering a code to open a door, a user can display an object, sometimes called a physical token, to identify him or herself. One of the most common types of physical tokens is an ID badge. New technologies now exist that do not require that the badge actually be visible. Instead, the badge emits a signal, radio frequency signal, identifying the owner. Badges that can be detected by a proximity reader, often fitted with tiny radio frequency identification tags, or RFIDs. Most of these proximity readers do keep an access list, which records individuals who have permission to enter a secure area, the time they entered, and time they left. You can also use a man trap. Man trap is designed to separate non-secured area from a secured area, usually in the form of a small room with two interlocking doors. When in operation, only one door is able to open at one time. You can also use video surveillance, which can monitor activity. This provides a degree of security as well, and as does fencing. So let's then talk about security of the hardware itself. Hardware security is the physical security that specifically involves protecting the hardware of the host system, particularly those host systems which are laptops, netbooks, tablets, etc., that can be easily lost or stolen. The first is a cable lock, which can be inserted into the security lock of a portable device and rotated so that the cable lock is secured to the device, and then the cable is connected or locked to a desk or immobile object. You can also store mobile devices in locking cabinets that can be pre-wired so that they are charging while they are stored. Mobile devices such as phones and tablets also have a range of unique security features. Some of these include a remote wipe or sanitation app. Devices lost or stolen. This provides a level of protection that can prevent the sensitive data from falling into the wrong hands. In other words, you can erase it remotely. Most of these devices have some kind of GPS tracking, which can detect the location of a portable device when it is lost or stolen. It also allows emergency responders to locate a person in a crisis, parents determine locations of their children, or just tracking any kind of phone location. Some of these devices actually have voice encryption as well, which can be used to mask the content of voice communications over a smartphone. Almost all of these devices have some sort of operating system that also needs to be secured. One of the first steps in securing the software operating system on a device is a security policy document that clearly defines the defense mechanisms an organization will employ in order to keep the information secure. To do this, you need to perform some kind of host software baselining so that once the policy has been created, the baseline is established. The baseline is the standard or checklist against which systems can be evaluated and audited for their security posture. Baseline outlines the major security considerations for a system and becomes the starting point for solid security. One of the first things you would need to do is to configure the security on the operating system. Modern operating systems have hundreds of different security settings that can be manipulated to conform to whatever baseline security you are attempting to have. Typical configuration baseline would include default settings that are insecure, like eliminating guest accounts, eliminating any unnecessary software devices or protocols, like removing games, and enabling operating system security features, such as tunneling through a firewall. Then, once that is configured, you would need to deploy these settings. In Microsoft Windows, a security template is a collection of security configuration settings. These can typically include account policies, user rights, event log settings, restricted groups, system services, file permissions, and registry permissions. Since they all have operating systems, they all probably have security patches to operating systems. So you need to implement some kind of patch management. A security patch is a general software security update intended to cover vulnerabilities that have been discovered, whereas a patch is universal for everyone. A hotfix is a software fix that addresses a specific customer situation and often may not be distributed outside that customer's organization. A service pack is software that is a cumulative package of all security updates plus additional features. Patches can sometimes create new problems, such as preventing a custom application from running correctly. Organizations that have these type of applications will usually test patches when they are released to ensure they do not adversely affect any customized applications. An automated patch update service is used usually to maintain patches locally instead of relying upon the vendor's online update service. An automated patch update service typically consists of a component installed on one or more servers inside the corporate network. They download the patches there, allow for testing, and then can simply be downloaded within the network's local area network from that server. And because these devices can get malware, we need to secure the devices with some kind of anti-malware software. First of which would be some kind of antivirus. Many antivirus products scan files by attempting to match known virus patterns or signatures against potentially infected files. This means the host antivirus software contains a virus scanning engine and has regularly updated signature files. A new approach to antivirus is a heuristic detection, better known as code emulation. In heuristic detection, a virtualized environment is created that simulates the central processing unit and memory of the computer, and then tests suspicious code in that environment. Also, you would need something for anti-spam. Beyond being annoying and disruptive, spam can also pose a serious security risk. Sophisticated email filters can use a technique known as Bayesian filtering. It's hard to say. Software divides email messages that have been received into two piles, possibly three piles, spam and not spam. The filter then analyzes every word in each email, determines how frequently a certain word occurs in the spam pile compared to the not spam pile. Whenever email arrives, the filter looks for the 15 words with the highest probabilities to calculate the message's overall spam probability rating. Some of those numbers are different in different filters. Mail host email clients can be configured to filter spam, such as creating or downloading a list of senders from which email is to be received, a blacklist, or from which no email is to be received, a blacklist. I can create a list from which only Email can be received, a whitelist, or a block email from entire countries or regions. Many email clients will also automatically block attachments of specific types. After anti-spam, we come to pop-up blockers and anti-spyware. A pop-up blocker can be either a separate program or a feature incorporated within a browser that stops pop-up advertisements from appearing. As a separate program, pop-up blockers are often part of a package known as anti-spyware that helps prevent computers from becoming infected by different types of spyware. You can also have host-based firewalls, which are usually software. Well, it is definitely software. This sometimes is called a packet filter. This is designed to prevent malicious packets from entering or leaving computers. A software firewall can be software-based or hardware-based. A host-based software firewall runs as a program on a local system to protect it against attacks. Another thing you need to do is monitor system logs. An audit log can track user authentication attempts, while an access log can provide details regarding requests for specific files on a system. Monitoring system logs can be used in determining how an attack occurred and whether it was successfully resisted. Security application logs usually include antivirus software log and automated patch update service log. Monitoring system logs is an important step that can benefit an organization in different ways. These would include a routine review and analysis of logs, helps to identify security incidents, policy violations, fraudulent activity, and operational problems shortly after they have occurred. Logs can provide information to help resolve such problems. Logs can be useful for performing audit analysis, supporting the organization's internal investigations, and identifying operational trends and long-term problems. Logs can also provide documentation that the organization is complying with laws and regulatory requirements. Finally, we come to application security. Application security includes application development and security, as well as application hardening and patch management. When you're developing an application, you should follow secure coding concepts. These standards help provide several benefits to development process. Coding standards can help increase consistency, reliability, and security of applications by ensuring that common programming structures and tasks are handled by similar methods and reduce the occurrence of common errors. Coding standards also allow developers to quickly understand and work with code that has been developed by various members of the development team, and coding standards are useful in the code review process as well as in situations where a team member leaves and duties have to be assigned to another. One of the important steps in developing secure applications is to account for errors, called exceptions, which are faults in a program that occur while the application is running. One approach is to trap for errors while testing the application code using fuzz testing or fuzzing. This is a software testing technique that deliberately provides invalid or unexpected or random data inputs. Application hardening is intended to prevent exploiting vulnerabilities in software applications. More application patch management systems are being developed to patch vulnerabilities. In other words, patch your applications as soon as the patch comes out. And finally, securing the data itself. The concept of work has changed dramatically over the last 30 years. Work today most likely involves electronic collaboration on smartphones, computers, tablets, wireless networks. This means data, once restricted to papers in a filing cabinet, now flows freely both in and out of organizations, among employees, customers, contractors, and business partners. One means of securing data is through data loss prevention, or DLP. DLP is a system of security tools that is used to recognize and identify data that is critical to the organization and ensure that it is protected. DLP typically examines data as it resides in any of three states: data in motion, and data at rest. Data that is considered critical to the organization or needs to be confidential can be tagged as such, and a user who then attempts to access this data to disclose it to another unauthorized user will be prevented from doing so. When a policy violation is detected by the DLP agent, it is reported back to the DLP server. Different actions can then be taken. The information could simply be sent to the to the administrator. Other actions could include blocking the data, redirecting it to an individual who could examine the request, quarantining the data until later, or even alerting a supervisor of the request. And remember, keep calm and don't forget to be awesome.